Hi friends, in today's class I am going to discuss the some of previous questions NEET and IIT-JEE means from oxidation number concept. There are total I could categorize the questions like level 1, level 2, level 3 questions. In today's class I can discuss the level 1, level 2 questions. So the level 1, so these are easy model, level 1. So easy, simple. So H2SO4, sulfur. So I want sulfur oxidation state. How can you find it? So first I will discuss the method. So +1 into 2. Sulfur is X. Each oxygen is -2 because it's not peroxide into superoxide. -2 into 4 is equal to 0. Why it is 0? Because this is neutral molecule. And there is no charge for H2SO4. This is neutral molecule. That's why for a neutral molecule, the sum of oxidation state is equal to 0. Then find the X value. X is equal to +6. So this is the method. Take one more molecule, potassium permanganate, manganese. Then how can you find the manganese? So potassium is always +1 because alkali metal +1. Manganese is X. Each oxygen is -2 into 4 is equal to 0. X is equal to +7. Take some polyatomic ions. SO4 -2. What is the sulfur oxidation state? Here sulfur is X. Each oxygen is -2 into 4 is equal to -2. Because for all polyatomic ions, the sum of oxidation state is equal to its charge. Charge of this ion is -2. That's why sum of oxidation state is equal to -2. Then find the X. X is equal to +6. Take one more. Cr2O7 -2. Dichromate ion. I want Cr. For 1 Cr, X. For 2 Cr atoms, 2X. Oxygen is -2 into 7. Each oxygen is -2 is equal to -2. Then X is equal to +6. KO2. I want oxygen. Then see here potassium is +1 plus 2X is equal to 0. Then X is equal to -1/2. The X minus 1/2 means oxygen oxidation state is -1/2. That's why it is a superoxide. Potassium superoxide. So take one more compound, like we can calculate any. So this is the method to find the oxidation number. So take one more, NH4 twice SO4. Ammonium sulfate, I want nitrogen. So for 2 nitrogen, okay, twice, that's why 2 nitrogens, 2X. Each hydrogen is +1. So here 8 plus 8. Total SO4 is -2 is equal to 0. Then here X is equal to -3. So this is the way to find the oxidation number of an atom in a compound, in any ion. For example, OH minus. What is the oxidation state of oxygen? X. Hydrogen is +1 is equal to -1, and X is equal to -2. What is the nitrogen oxidation state in N2? That is 0 because elementary state. What is the iron oxidation state in Fe+3? Okay, for monoatomic ions, they charge nothing but their oxidation number, so +3. So this is the way to find the oxidation number. These are easy level. Now come to the level 2. So in level 2 questions, all are previously, they are already asked in previous exams. Level 2. Okay, somewhat difficult level. So take first one. H2SO5, it is very important acid. This is called peroxymonosulfuric acid. The commercial name for this acid is Carros acid. Okay, H2SO5. Here I will discuss the two methods. Okay, with structure one method, without structure one method. For example, if you don't know the structure of this H2SO5, then how can you find the sulfur oxidation state? First, normal way find the sulfur oxidation state here. Hydrogen is +1, the level 1. So what I taught in earlier, level 1, same method, +1 into 2. Sulfur is X. So oxygen is, each oxygen is -2 into 5 is equal to 0. Then what is the X oxidation, sulfur oxidation state here? +8. So does +8 is possible for sulfur? For sulfur, group number is 6. Okay, that's why for sulfur, the maximum oxidation state possible is +6. So +8 is not possible for the sulfur. So this is wrong. So it is wrong. So in this case, let us assume, so when you get the more than its oxidation state, maximum oxidation state, so +8 not possible for the sulfur, +6 only maximum. So when you get the oxidation state, it's more than its maximum oxidation state, then there is a method. Let us assume presence of one peroxy bond, one peroxy bond. So we have to assume presence of one peroxy bond. So what is the peroxy bond? In previous session, I could discuss in part 1, oxidation number part 1, I already discussed what is the peroxy bond. So O2-2 ion is called peroxide ion. It is peroxide ion. Okay. So what is peroxy bond? In O2-2, there is a single bond between two oxygen atoms. Here -1, here -1. So this bond is called peroxy bond. Okay, in peroxy bond. So in peroxy bond, the oxygen oxidation state is -1. Okay, if any oxygen involved in the peroxy bond formation, then oxygen oxidation state is -1, because so this oxygen contribution, its charge is 0. This oxygen contribution towards this charge also 0. So when the bond is present between two similar atoms, then their contribution, charge contribution is 0. So -1 here, -1. So total -2. Okay. Then oxygen oxidation state in peroxide is not -2, that is -1. So peroxides oxygen oxidation state -1, whereas oxides -2, superoxides -1/2. So that information I already given the part 1. See the part 1 video. If you want this information, you can see that, you can watch the part 1. Then see here, come to the assume presence of one peroxy bond. Okay, out of 5 oxygens, so 2 oxygens involved in the peroxy bond formation. So to form the one peroxy bond, how many oxygens required here? 2 oxygens. That's why H2SO5. H2SO5. So hydrogens are +1 into 2. Sulfur is X. Out of 5 oxygens, 2 oxygens involved in the peroxy bond. For these 2 oxygens, -1 oxidation state. So for remaining 3 are normal oxide form, -2. This is neutral molecule, that's why sum of oxidation state is equal to 0. Now find the X value. So +2 -2 get cancelled, +6. So this is correct. So H2SO5, in H2SO5, the sulfur oxidation state is not +8, +6. +8 is not possible, +6 possible. So you can follow this method. So if you don't know the name, even the if you don't know the structure of the molecule, there is an alternative method. If you know the structure of H2SO5, you must know the structure of H2SO5, because you will get structures of sulfur oxy acids in second year P-block elements. You must know this one structure. For example, if you don't know the structure, you can follow this method. If you know the structure, it is very easy to find the sulfur oxidation state. See the alternative method, second method. This is second method. H2SO5. So what is the structure of H2SO5? See here. There is a one peroxy bond. One peroxy bond. So double bond go. The sulfur maximum valency is 6. Around sulfur, how many bonds are there? 6 bonds. Like that you can write here. Okay, this is the peroxy bond. So for these two oxygens, -1, -1. If you know structure, it is very easy. So -1, -1. Remaining 3 oxygens are -2, -2. This is +1 and this is +1. Now find the sulfur here. 2 hydrogens are +1 into 2. Sulfur X. And these 2 oxygens are -2. Remaining these 3 oxygens are, okay, these 3 -6 is equal to 0. Then X is equal to +6. Directly you can find it. So this is second method through structure. If you know the structure, so knowing the structure is very easy compared to the previous method. So sometimes they will ask how many peroxy bonds are there in H2S, so Carros acid, one peroxy bond. Okay, like in the same way, one more example, H2H2O8. This is called peroxydisulfuric acid or Marshall acid. Marshall's acid. So in this sulfur, what is the sulfur oxidation state? Okay, first I will discuss the first method, thereafter second method. So you can follow as your wish. For example, if you don't know the structure of this peroxydisulfuric acid, then you can follow this method. So find the normal way first. Hydrogen is +1 into 2. 2 sulfurs are 2x. Each oxygen is -2 is equal to 0. Then here X is equal to +7. So +7 is not possible for the sulfur. So this is wrong. So it is wrong. Now what is our assumption? Let us assume presence of one peroxy bond. Presence of one peroxy bond. Okay, assume here. Then take one peroxy bond. So to form the one peroxy bond, so how many oxygens are required? 2 oxygens. So out of 8 oxygens, 2 oxygens involved in the peroxy bond. So for these 2 hydrogens, +1 into 2. So 2 sulfurs, 2x. So out of 8, 2 oxygens are -1. Remaining 6 oxygens are -2 is equal to 0. +2 -2 get cancelled. Then it is X is equal to +6. So this is correct. Okay, this is method 1. See the method 2, alternative method. If you don't know the structure, follow the method 1. If you know the structure, I know the structure of H2H2O8. This is the structure. So this one is the structure. OH. It also OH. See, if you know the structure, you can easily predict how many peroxy bonds are there. One peroxy bond. So for 2 oxygens, directly you can take -1, -1. For these 2 oxygens, -1, -1. Remaining all oxygens are -2, -2. Now find here H2S2O8. So 2 hydrogens are +1 into 2, plus 2 oxygen, 2 sulfurs are 2x. So these 2 oxygens are -1 into 2, plus remaining are 6 oxygens, -2 is equal to 0. Then directly X is equal to +6. So this is the important question. And third one more example. That is very, very important. Third one. CrO5, chromium pentoxide. Many times, many examinations they given this question. CrO5, chromium pentoxide. So chromium pentoxide, it has the butterfly shape. So first we'll follow the first method, chromium. If I don't know the structure, first method. So chromium is X. Each oxygen is -2 into 5 is equal to 0. Then X is equal to +10. So that is not possible for the chromium. Chromium, what is the group number? Cis to B. Cis to B means maximum state possible for chromium is +6. Otherwise, you can write the electronic configuration of chromium. So chromium electronic configuration argon 3d5 4s1. Exception in the electronic configuration 3d5 4s1. Even though if it lose the total 3d and 4s electrons, maximum state possible for the chromium is +6, not +10. When you get the more than its possible oxidation states, then what is our method? Let us assume presence of one peroxy bond. So to form the one peroxy bond, two oxygens are required. So this chromium X, and out of 5 oxygens, for 2 oxygens is 2 into -1. 2 into -1. So remaining 3 oxygens are -2 is equal to 0. But still X is equal to +8. That is also not possible. That is wrong. Now take one more presence of second peroxy bond. So let us assume presence of second peroxy bond. So so presence of two peroxy bonds. So chromium X as usual. To form the two peroxy bonds, how many oxygens are required? 4 oxygens. For 4 oxygens, -1. Remaining oxygen is -2 is equal to 0. X is equal to +6. So this is correct. So you can follow this method when if you don't know the structure. But I know the structure. Sometimes knowing the structure also important. So because this is easy, second method is easy. So there are two peroxy bonds. So this is OO bond, one peroxy bond, other OO bond, one more peroxy bond. So two peroxy bonds are present. So for these two peroxy bonds, here two peroxy bonds, -1, -1, this oxygen, -1 and -1. For this oxygen, that is -2. Then what is the chromium oxidation state total? That is +6. So CrO5, so two peroxy bonds. So how many oxygens have -1 charge, -1 oxidation state? 4. Other one oxygen is like oxide form, -2. So directly you can take chromium is X, 4 oxygens -1. One more oxygen, that remaining oxygen is -2 is equal to 0. X is equal to +6. So it has the butterfly shape. The shape of this molecule seems to be similar to a butterfly. That is called butterfly shape. So take level 2. Take one more. CaOCl2. Calcium chlorohypochloride, that is called bleaching powder. In bleaching powder, what is the chlorine oxidation state? I want chlorine oxidation state, that is 0. So chlorine has the two different oxidation states here, +1 and -1. So see how it is. So it exists as ionic form Ca+2, and two ions are there, Cl and OCl. For this one -1, for this one -1. Like this it will exist, ionic form. So there are two ions, chlorine present in the form of two ions. One is Cl-, other one is OCl-. Okay, in Cl-, what is the chlorine oxidation state? -1. In OCl-, what is the chlorine oxidation state? Oxygen is -2. Cl is X is equal to -1. But what is X here? +1. Here Cl is +1 oxidation state. Here chlorine shows the two different type of oxidation states, +1 and -1. Then what is the average oxidation state of chlorine? Average oxidation state of chlorine is +1 -1 by 2. +1 -1 by 2, that is 0. So that is the average chlorine oxidation state. One more, NH4NO3. Here also nitrogen shows the two different types of oxidation state. This compound exists as ammonium nitrate, ammonium cation, always ionic form, NO3-. So two ions are there. In NH4 plus, what is the nitrogen oxidation state? X -4, X +4 is equal to +1, then X is equal to -3. Here nitrogen is -3. And like in the same way here, nitrogen, X, each oxygen is minus 2 into D is equal to minus 1. Then X is equal to here plus 5. So here minus 3 nitrogen, in this nitrogen is plus 5 oxidation state. So these are the level 2. So level 3 difficult level, that is fractional oxidation state. So don't miss the part 3 oxidation number. So that is very important for IIT JEE exams. That's all for today's session. Thank you.